This is a follow-up on a video I had done some earlier ones on machining gears, and I wanted to case harden the gears, and it was expensive to have them case hardened, and I'm kind of glad initially I didn't, because I did have to make some changes in the gears on how to do some more machining for clearances, and if they were case hardened then I wouldn't have been able to do it very easily. So in a way it was good that it got delayed. But I'm finally at the stage now where the gears could be case hardened at this point in time. But I decided to build a kiln to do the job. I went on the internet and saw a lot of different designs, and so I kind of came up with my own design. What you're seeing here is this whole, the kiln is made of fire brick internally, and these are the bricks. These bricks are for, this marked for 2600 degrees. You can see that there. And what I did was, I saw a lot of designs that the kilns were, the frame was steel. And that made it very, very heavy, and I was trying to avoid that. So what I did was, this whole frame of the kiln is actually all aluminum, bent aluminum, and it's a 1/4 inch thick. And I actually bent it up and welded it. It's all TIG welded, all the seams. I'll rotate it around so you can see it. And what's unique about this, which I really like, is sometimes you want to fire a tall object or a long object, depending on what you want to do. So I'm going to open up the kiln. I have these latches here, and I open it up, and you can see the kiln is 18 inches deep and about 12 by 12 here, and you can see the fire brick and heating element is here, and then the gasket is there. So the whole thing is welded aluminum, as I said before, and there's aluminum sheeting on the outside of the whole kiln, and that's done to protect the fire brick, because the fire brick is very soft, and you could actually cut it with a handsaw, which I did. But since I didn't want to bolt it, because I wouldn't have the rigidity. So in fact, as I said before, I TIG welded it, and that made it very strong. And I had to do it in sections, you know, the door section, the main body section, the mounting. It was just done in sections, and then finally put together. Now the thing that's unique about it, let me show you. I didn't want it to be a tabletop because it's quite heavy. I'd say it's probably 150, 200 pounds, somewhere, so 150 pounds. I haven't weighed it exactly, but I wanted to be able to move it around fairly easy and go from horizontal to vertical position. So what I did was, I'm going to pan down. I made this frame and I put it on wheels, as you can see, so I could move the kiln around quite easily. And the other thing that I did to make it easy to operate is I have it so I can tilt it by pulling 2 pins. This pin and this pin here is out already. I can go from horizontal to vertical, and then put the pin back in again, like this. And now the kiln is locked in the vertical position, so I could do tall objects and not have to lay them down. I use 2 pins per side. It's only pinned on one side, not both. Just for safety reasons, I put in 2 pins. These pins here are the pivot pins, and they stay in all the time. They're spring-loaded pins, as you can see, and they stay in all the time. So and I can actually remove the kiln from the frame if I have to, if I need to transport it, by pulling the 2 pivot pins, one on each side. There's one on that side, pulling the pins out and lifting the kiln out. But this seems to work fairly well. I'm going to turn it back to the horizontal position again. And I have it so I can put the pins in once I get it aligned. There it is there. And I put this one as a safety, just in case. And of course, I said I had extra pins. Now, the other thing that's unique about it is you have to have a thermocouple with this controller, and the thermocouple was designed to go in two locations. If you operate it in the vertical direction, the thermocouple goes in the center at the top, screws in like that. If you operate it in the horizontal position, the thermocouple goes in the back, about 6 inches away from the back of the unit. Turn it around, and you can see the thermocouple is right here in the back. So that makes it very versatile. And also, this was built also, my wife does ceramics, and this was built to also fire ceramics. It's basically a kiln is the same, whether it be for ceramics or metal. And that was one of my inspirations to go vertical or horizontal, because if she fires tall pieces, it's got to be in the vertical position. Now, I do have a much larger kiln that's used for ceramics. It's quite large, probably about 3.5 feet tall, and got to be 25 inches in diameter. But this one was made for firing small ceramic pieces, and also for case hardening gears. The thing that I like about this is the PID controller that's from Inkbird. Let me bring it up. Inkbird sells this. I forget how much I paid. It wasn't expensive, $30, $40. And this here is the volts and amps when it's plugged in and it's drawing. Power on switch, power on indicator, and alarm. And what this alarm does, is when the kiln comes up to the temperature that you want, the heating element stops producing heat. It gets shut off, even though the controller stays on and the alarm goes off. So if you're someplace not too close by, you're on the other side of the room, when the kiln reaches the desired temperature, the alarm goes off, the current goes down, so you're no longer producing heat, and it alarms until you either shut it off or disable the alarm through the controls here. Let me show you the schematic first of it, and then we'll talk about I'll show you the electronic. This is the schematic of the controller. Power in, 2 10-amp fuses, 220, current sensing, on and off switch, indicator light, and of course over to the load, the solid state relay. This is the PID, and this is the probe sensor. And what I did a little different was, they have an alarm relay that what it does is when you set the temperature and it alarms, you could wire it to do several things, either make an alarm or shut off the input to the solid state relay and the alarm goes off. So what I did was, I have it set up so when the alarm goes off, it shuts off the solid state relay and sounds the alarm at the same time. This way I know that it's up to temperature. So let me show you I left this cover loose so I can show you the inside. I put holes in it. The whole thing is sprayed with hammer tone, which gives it a very nice finish. And let me tip it so you can see some of the wiring, how it was done. I try to get it as balanced as best as possible, but that was at times a little challenging. So here we have the electronics, and let me see if I can get a better position so you can see how I wired it. The fuses right here, the 220 in, terminal bus so I can distribute the power where it needs to be, solid state relay, the alarm right here, and here this is the volt amp display, and this is the PID, Inkbird PID, and then of course the wiring. So I do have the cover up. The cover goes on and kind of makes it pretty safe to operate because there's nothing exposed. Let me put this back up, and I'm going to plug it in so you could see the operation. Let me get the cover. Put the cover back on. I will screw the cover on. Right now I'm just sliding it over just so that the electronics aren't exposed. Oh, the back of it, let me show you the back of it, how I have it wired in. I have the heating elements, and I have to do something a little bit better with this. I'm working on it. The heating elements come through on both sides. They are in series, and I have to, this is going to get covered up with aluminum cover so nothing's exposed. Right now there's 220 on these terminals, but in fact it's going to be covered. I haven't picked up a cover yet. It's going to be a cover with a tie wrap and a cable clamp so it holds it against there like that. But I haven't picked that up yet, and I will be picking it up soon. So what I'm going to do now is I'm going to plug it in and turn it on. It's 220 single phase. I did put a fairly long wire on it. I think I have a 10-foot cable. It only draws 10 amps, so it doesn't draw a lot of current. Flip it on, and right now you can see 238 volts, 9 amps. Right now the top one is the actual temperature, and the bottom one is my set temperature, and the output says out right there. I don't know if you can see that. Let me bring it closer. The output light is lit right here, and it's showing that the output is it's on, and you can see I'm drawing current. And going through the Inkbird is a programming sequence. I'm not going to cover it because it was covered on the internet before, and the gentleman did a quite nice job of covering the programming of it. I'm going to open it up. It's on right now, and you can see that it's glowing in there. And so that's kind of it as far as what's going on. I've already had it up to about 900 degrees. I'm not doing high temperature for this demonstration right now. It's not necessary to just make heat for no reason. I do have the alarm set right now. The alarm, I believe, is set for, let me see what it's set for. I don't remember. So you program through each one of these alarm. Okay. Right now I have the alarm set. High alarm is 319 degrees. Whoop. Let me bring this up. Sorry. Right now the alarm is set for 319 degrees. As you can see, I'm getting smoke. I have a insulation back there that the wire has to get tight. But anyway, the alarm will go off when the temperature reaches 319 degrees, and then this will sound the sonar sound, and then you either shut the kiln off or you have to disable the alarm by going into software. So that's kind of where we stand right now. Anyway, I wanted to show you that so you can see how it came out. It came out quite nice, and I will be firing it up soon to actually try something, but at this point in time, I'm just showing you how it's done. And that should do it for this video.